Good afternoon. Last time we have seen the basic lectures on the descriptive statistics and frequency analysis. Now we have to proceed with the comparison of mean. So now let's start with the how to proceed with the comparison of mean. So today basically we'll discuss about the procedures of Now this comparison of means involve two basic tests. One test is about the t-test and another test is about the ANOVA test. So the first is the t-test. We'll discuss in detail about the t-test, and another test is about the ANOVA. Right. So let's start with the what do you mean by the t-test and where you require the t-test analysis. So t-test includes basic test regarding the one sample t-test. So that is one sample t-test, and one sample t-test. So if I explain about the test statistics, so that test statistics we can write here as t, that is x bar minus the hypothesized mean divided by its standard deviation by its sample size. So here you can consider it as a standard error of mean, and here you can consider the sample mean by the hypothesized mean. So if let's say if my hypothesis h naught is mu is equal to 30, so if I have sample from, let's say this xi is equal to let's say 10, 12, 13, likewise it is 15, then if the average is like mu is equal to, that is 30 that I have to test, and the sample average that x bar is comes around let's say 30.29, right? So as you can see here, the difference is 30 and 30.29 minus 30, that is 0.29 difference is there. Now as I have to check whether this difference is significant enough to say that there is a difference from the hypothesized and the sample mean, then I have to carry out the test procedure. So that test procedure includes first of all to construct the test statistics that we have written, that is x bar minus mu s by square root of n. That is my test statistics. So through this test statistics, what I will do, I will calculate the calculated value, that is t calculated, and let's say that is 2.13. Now this calculated value to take decision about to reject h naught, I have to compare with the table values. So that table value let's say t tabulated, so it's around 2.29, right? Then by looking at this calculated and tabulated value, I have to compare this. If it is greater than the tabulated value, then I can reject that. But now to compare the tabulated and calculated value, this part is now taken care by the software. So that software, the case studies, when we perform the case studies with respect to different softwares, that is SPSS and SAS. So that we'll see in software like how to operate the SPSS and SAS to carry out the t-test. So now if I have to take decision based on the t calculated, that is calculated from the x bar minus mu s by square root of n, where I have to find the p values. So this p value, if I have to interpret this p value, so this p value I can interpret like this way. So what do you mean by the p value? So p value is the maximum probability of rejecting h naught. So as an analyst, my aim is to reject h naught, but to reject h naught I have to provide sufficient evidence, because without providing sufficient evidence I can't reject this h naught. That's why what I will do, I will collect the samples. So that is what I am trying to collecting the information. So this information when I have collected, now whatever information is contained in the sample through which x bar I will calculate, and through which I can take decision whether this x bar is deviating actually from this by chance, or actually there is some deviation. So that's why what I will do, I will compare this sampling distribution, that is t, and I will calculate the p value. So as we have mentioned that p value is nothing but the maximum probability of rejecting this H naught. So this p value is the area probability up to the calculated value. So software will calculate this area probability. Now let's say if it is 0.02, what it means, if p value is 0.02, that means I am committing 2% error in rejecting H naught, right? Now 2% error by rejecting H naught, that means what, this calculated value is lies under the critical region, that is 0.05, that is your level of significance alpha, and this alpha value is covered under this calculated value. So this calculated value is 0.02, that means it is fall into the critical region, right? So in that way also you can interpret. Now if p value is 0.02, that means 2%, there is a 2% chance, right, to take a wrong decision to reject the H naught. So yes, I can take decision with this low error, or you can interpret that okay, I am committing 2% error in rejecting H naught. So management has allowed me to commit up to 5% error, right? So as in last lecture we have discussed about the testing of hypothesis, where also we have discussed about what is type 1 and type 2 error. So that concept if I utilize here, that is about type 1 and type 2 error. So where we have also discussed like which error is more significant. So as we have concluded the type 1 error, that is the manufacturer risk, that is more significant for the production point of view. So type 1 error I have to fix, that is what I am fixing the level of significance, that is alpha, that is 0.05. Now this 5% error that management is allowing me, okay, if you are rejecting H naught, that fine, but you have to provide sufficient evidence that you are not committing the error beyond the 5%, right? Now if I am committing error beyond the 5% and I am rejecting H naught, let's say if it is related to the gear manufacturing, like the mean diameter is 30 which I have to produce, right? And if I am committing like p value comes as a 0.006, that means I am committing 6% error, right? With this 6% error, if I am rejecting this H naught, means what, right? If my H naught is true, still I am rejecting that. That means there is a loss in terms of the, if there is a good lot in terms of production, still I am holding that lot to the company, right? I am not, and that lot is not able to go to the market. So that's why in that way there is a risk for the manufacturer. What is that risk? That is the good lot is not able to go to the market because of that wrong decision to reject the H naught. So this is how I can proceed with the one sample t-test, where I can check the claim of like regarding anything. If it may be like error per page, that is the claim, or you can say average time, that is also claim, that is average duration of the services, that is also claim. So if such kind of claims are there, right, so and you have one sample, so you can proceed with the one sample and you can test the procedure, and you can check whether this and you can take decision whether you have to reject this claim or not. And that we have discussed with the p value, that okay, if you are in sufficient position with respect to the information, if you have sufficient information to reject that, yes, you can reject that H naught. In that way you can take decision. Now also there is one important criteria also we have discussed in the last lecture, that is about the confidence interval. So this p value is also directly related to that confidence interval. So here you can see that confidence interval, if for this mean, so x bar, this plus or minus t s by square root of n, right? Now here if the confidence interval and the mean difference, that is mean difference of this x bar minus mu. Now if mean difference, the confidence interval, that is xd, that is about difference, and if it is let's say 0.01 and 0.05, so here you can see that this confidence interval both have the positive signs. That means 0 is not included. Now 0 is not included means what, right? This mean difference, that is what the H naught, and this is our claim, that is x bar minus mu 0 is equal to 0. So if this 0 is not included in the confidence interval, means it is called the 95% confidence interval. So right now we are testing on the alpha, that is level of significance is 0.05. So 95% chance that there will be no 0, right? So there is a chance that if you are producing the particular product, every time it is deviating from the mu 0, that is the population mean. So that is what the claim. That means whatever sample information is contained, that proves that your claim is deviating from that sample mean, right? So that is also one of the interpretation you can take from the 95% confidence interval. Like if it is let's say minus and this is plus, right? So that means your confidence interval contains that 0. That means if you collect the 100 samples, so 95 times there is a possibility to having that 0, right? Because this negative and positive sign, that means that 0 is contained in the confidence interval. So that confidence interval, so you can say that it is insignificant, right? So whatever claim is that means sample mean is approaching towards the population mean 95 times. So yes, that is true, right? But that claim we can check from by looking at the confidence interval, right? So now we can proceed with this 2 sample t test.